So, welcome to the class. Today we will see how to solve a problem on compression of soil. Means if you have to find the coefficient of compressibility, what is coefficient of consolidation, everything, and find out how much it will get settled total displacement, how much the total thickness, final thickness should be of the soil after a compressive load is applied on it. You're going to find out. Okay. So the clay here it is given that a clay soil of 25 mm is a problem. A clay soil of 25 mm thick was tested on a laboratory allowing drainage both sides. Okay. The soil gets drained on both sides. This is one important point in the problem. The specimen showed a decrease in volume ratio from 0.92 to 0.78 when the pressure has increased from 60 to 120 into per meter square. Okay, so as the stress increases, the void ratio decreases of a soil specimen of 25 mm thickness. Okay, so the height is 25 mm of the soil. Calculate the coefficient of compressibility, coefficient of volume change, and coefficient of consolidation if time for 50% consolidation was 5 minutes. Determine the soil permeability and calculate final thickness of the specimen at the end of the test. So all these things are asked. So you have to know what is coefficient of compressibility first, then what is coefficient of volume change, then what is coefficient of consolidation, and how you can find out these things, and then how to find the final thickness of specimen at the end of the test. ये अपने को निकालना है यहाँ पे, ठीक है. So first we'll see one by one. So first, so when a pressure is applied on the soil, okay, if there is a soil, for example, wait a second, okay, so if this is a soil having depth d, okay, having depth d and certain pressure is applied, so there will be reaction from downward also, obviously. Okay, let that pressure be P. Okay. So due to pressure P, the soil will get compressed, means its thickness D will reduce to certain other thickness less than D, obviously. Why that will happen? Because the soil consists of, the volume of soil consists of soil particles, and within which are compressible particles which can get compressed, and within the soil particles there are voids or blank spaces. In that voids, air can be filled or water can be filled. Okay, both can be present at the same time. Only air can be present or only water can be present. Okay? So as you apply the pressure on the soil in vertical direction, and if there, then what happens, due to the pressure, the void ratio gets reduced, means the voids gets reduced, obviously. What are the reasons of voids getting reduced? First reason can be expansion of air and water. Next will be the rearrangement of soil particles. Next will be the compression of the soil particles. All these reasons causes the soil depth to decrease or soil to get compressed, as you can say that. So compression of soil, okay, due to applied pressure is due to whatever the voids presence are there, from the voids air and water gets gets expelled. Okay, okay, air and water particles gets out from the voids of the soil. Okay, and also the soil particles get rearranged. Okay, then another reason is that compression and deformation of soil particles can also takes place. Okay, and compression of liquid and gas within the voids can also takes place. This is very later point. The first point is that compression and deformation of solid particles, rearrangement of solid particles, exclusion of air and water in the voids takes place. These are the main reason for compression of soil due to applied pressure. Okay. Then compressibility is defined. So what does compressibility means? Is defined as the resistance against volume decrease when the soil is subjected to a mechanical load. Okay, is a resistance against the volume decrease. Thus it is described by the shape of the stress strain curve. Compaction test are used both for laboratory and field soil compression characterization. Okay, so before going further, let's see what is coefficient of compressibility. Okay, so as the pressure are applied, the water is decreases in this way. Okay, it doesn't decrease exactly linearly, it decreases in a linear shape, okay. So for that we can say that the coefficient of compressibility is denoted as AV. Coefficient of compressibility is denoted as AV. AV is nothing but change in void ratio, that is delta E, by change in effective stress, that is delta sigma bar. Okay, change in void ratio means what? If this is E1, then this is E2, this can be sigma 1 and this can be sigma 2. So that will be what? Equal to E1 minus E2 by sigma 2 bar minus sigma 1 bar. This can be considered as a coefficient of compressibility. Okay, that's it. Okay, so that's a coefficient of compressibility. Next, what is coefficient of volume change? Now we have to find, as the depth decreases, the volume also decreases. The change in volume also occurs in the soil. Since the voids are getting reduced, the volume also get reduced of the soil. So coefficient of volume change is another point we have to find out, is the ratio of the change in volume of the soil to its initial volume due to an increase in pressure. It is the ratio of compressibility modulus and has units of meter square per kilometer. Simply you have to understand coefficient of volume change is denoted as mv. Okay, m suffix v, and it is written as AV, that is coefficient of compressibility divided by 1 plus E0, where E0 is initial void ratio before the stresses or the pressure is applied. Okay, so coefficient of volume change mv is nothing but coefficient of compressibility, that is AV, divided by 1 plus initial void ratio. Okay, so coefficient of compressibility is, first is AV. Coefficient of compressibility is nothing, AV is written as delta E by delta sigma bar. Okay, and from that we can find the coefficient of volume compressibility, that is mv. Okay, delta E can be also written as E0 minus EF, and mv can be written as AV by 1 plus E0. It can also be written as AV can be written as delta E by 1 plus E0 into delta sigma bar. It can also be written that way also. MV can be written in this way also. Okay, so that is coefficient of volume compressibility, that is MV, or coefficient of volume change. Its unit is meter square per kilonewton. Okay, so that's it as coefficient of volume change, that is mv. Coefficient of compressibility, that is AV by 1 plus initial void ratio. Okay, that's the thing. Next we have to find, so compressibility is over, now we have to find the coefficient of consolidation. Okay, so is the measure, coefficient of consolidation is a measure how quickly soil consolidates under load. Okay, it is key parameter in geotechnical engineering for calculating time it takes for the soil layer to settle. Okay, how quickly soil consolidates under load, that represents coefficient of consolidation. Okay, it calculates the time it takes for a soil layer to settle. The coefficient is given by the equation, you can see in further. But first we will answer that. What is coefficient? Is the rate at which saturated soil undergoes consolidation. Okay. In coefficient of compaction, compaction occurs due to expulsion of, if you compression, sorry, if you see the compression is defined as resistance against volume decrease in the soil subjected to mechanical load. Okay. And compression occurs due to expulsion of air or water from the voids of the soil, whereas coefficient of consolidation is the rate at which saturated soil undergoes consolidation. Okay. Saturated soil, okay, it's not dry soil, is not partially saturated soil, is fully saturated soil. Okay. At the rate at which means the voids are fully filled with water only, there is no air in the voids of the soil particles. Okay. So the time, for that we have to find certain time factor which is given as Tv is equal to CVT by d square. Okay. And that Cv is nothing but coefficient of consolidation. That Cv is nothing but coefficient of consolidation. T is the time taken for a certain percentage or certain degree of consolidation, and D is the depth of drainage, how much drainage depth is provided. So we will decode this particular equation. What does this mean? So TV is nothing but the certain time factor. Okay. So there is another term is given, that is degree of consolidation. Okay. There is one thing we have to find, the coefficient of consolidation. Coefficient of consolidation is nothing but CV. Okay. Before that we saw that coefficient of compressibility is written as AV. Okay. This is coefficient of compressibility. Coefficient of compressibility. Okay. Okay. And AV is given as coefficient of compressibility delta E by delta sigma bar. Okay. Whereas to find coefficient of consolidation, coefficient of consolidation, CV. Okay. So CV, for CV we have to find, we can find by using time factor formula. TV is nothing but CV T by D square. Okay. CV T by D square. Okay. So how you will find now this TV? So this TV, that is time factor, is another formula, that is TV can be also written as pi by 4, that is the, you can consider as the area formula of area of circle, that is pi by 4 u percentage by 100 square. Pi by 4 u percentage by 100 square. Now what is this u percentage? U percentage is nothing but degree of consolidation, that is considered as degree of consolidation in a given time t. Degree of consolidation in a given time small t. So this t is this particular t, as you can see. Okay. So we will just go again in front. Coefficient of consolidation. So you can also say that coefficient of consolidation. What is coefficient of consolidation? It is represented as CV. Okay, measures one dimensional consolidation in which when soil experiences no lateral strain. So there is no lateral strain, means if the soil particle is this much, having depth D or having height H, okay, and if pressure is applied from two opposite sides, so there is no lateral strain. Lateral means horizontal direction. There is no change in dimension is horizontal direction. Whatever the change in volume occurs is only in vertical direction only. There is no bulging, there is no bulging of the soil part of the particular soil sample, whatever. Okay, and this change in volume is only due to longitudinal strain only, and this occurs due to the total voids which are filled, which are fully saturated or which are fully filled with water. The water gets uh, displaced, or water gets out from the soil in vertical direction only. Okay, so in a given geotechnical lab, you can take a saturated clay sample. Okay, okay, we need a saturated clay sample for that, and we keep that particular saturated clay sample in a laterally confined space. In a laterally confined means this is confined along the height, it is confined in a glass jar, and pressure is applied from upper side this way, and this is like a fixed place here. So obviously whatever change in the volume occurs in the soil sample, there is no lateral strain. In this, the laterally volume doesn't increases, only linearly volume gets reduced, and that volumes reduces because of the voids ratio getting reduced, or the voids getting reduced after the expulsion of water from the voids. Okay, so coefficient of consolidation measures one dimension, hence it is considered as a one dimensional consolidation, means only in one dimension consolidation is taking place. Okay. Okay, so now we will go further. Okay, so coefficient of consolidation measures one dimensional consolidation, which is when soil experiences no lateral strain. This is acceptable for most practical problems, but it is acceptable to assume that seepage and strain occurs only in vertical direction, as I have told earlier. Okay, so the unit of coefficient of consolidation is centimeter square per second. Okay, coefficient of consolidation CV has unit centimeter square, that is area per time. Okay, so we have got now everything. So what is coefficient of compressibility? Okay, understand, this is compressibility coefficient, that is AV, that is delta, change in void ratio or change in effective stress. Okay, then there is another thing, that is MV, coefficient of volume change, that is coefficient of volume change can be written as AV by 1 plus E0. Then we have to find the CV, that is coefficient of consolidation. Understand, this is consolidation, coefficient of consolidation. Okay, which is can be found out by TV is equal to CVT by D square, and this TV can be also written as pi by 4 into U percentage by 100 square, where U percentage is nothing but degree of consolidation, is nothing but degree of consolidation. Okay, so these are the things. Okay, now we will go further, and now we will solve the problem. Okay, so now we will solve the problem. So in this problem, as you can see, the soil specimen's height is given. Okay, so height of the soil specimen is 25 mm. Okay, and when the stress goes from 60 to 120 stress, that is this is sigma 1, this is sigma 2. It goes from 60 to 120. Void ratio decreases from 0.92 to 0.78. So from this given data we can directly find the coefficient of compressibility, that is AV, that is delta E by delta sigma bar. So that can be written as E2 minus E1, या फिर in this case that is E0 we can also consider as, then that is sigma 2 bar minus sigma 1 bar. Since it is not written that it is effective stress, then also we can consider effective stress, because effective stress is nothing but total stress minus pour water pressure. Okay, so you can write this as 0.92 minus 0.75 divided by 120 minus 60. So that comes out to be 2.33. That comes out to be 2.33 into 10 raised to power minus 3 meters square per kilosecond per kilonewton into 10 raised to minus 3 meters square per kilonewton square per kilonewton. So that is coefficient of compressibility. So we just found coefficient of compressibility. Okay, now we have to find MV, that is coefficient of volume change. The coefficient of volume change is written as coefficient of compressibility AV divided by 1 plus initial void ratio, that is E0. Okay, so it is can be written as 2.33 into 10 raised to power minus 3 by 1 plus initial void ratio was 0.09 0.92. So that comes out to be 1.215 into 10 raised to power minus 3 meters square per kilonewton. Okay, so that's another thing we have found out right now. Okay, so next, now we have to find what? Coefficient of consolidation. Coefficient of consolidation is written as CV. Okay, CV. For coefficient of consolidation finding, we know that TV, that is the time factor, is nothing but CV T by D square is equal to nothing but pi by 4 U percentage by 100 square. That is given here. Okay, so what is U percentage? So U percentage is nothing but degree of consolidation. So it is written as whenever the percentage consolidation is given, all they consider it as, always consider as U, that is degree of consolidation. U percentage is given as 50%. So we can directly find the TV in this case. So for finding TV, so we can find TV, that is the time factor, is nothing but pi by 4 into 50 by 100 whole square. So TV comes out to be 0.196. As soon as you find TV, you can write this equal to CV into T by D square into T by D square. Now what is T in this case? T is given in the problem. What is T given in the problem? It's 5 minutes. Right? So time is given as 5 minutes. So 5 minutes in what is in seconds? CV into 5 minutes into 60 seconds. Okay, 60 seconds in 1 minute. So in 5 minutes there will be 300 seconds. And what will be D? D is not the exactly, you should not consider D as the whatever the given depth. In this case the given depth is what? 25 mm. You cannot consider directly. you have to read the problem first. In the problem, if it says that the drainage, allowing drainage both sides, okay, so allowing drainage both sides, then only we can directly consider this D as equal to 25 mm. Okay, means when the pressure, means there is void percolated plates, okay, the having holes in it, the plates from which when pressure is applied from both sides, the particular water has the maximum distance which it can cover to go out is D. Okay, if there is a water particle here, and if it doesn't percolate from here, and if CP is from here, so it has to cover a total distance of D. So D is nothing but, so you can understand this way also, when drainage is applied on both sides, D can be considered as the total initial depth of the soil sample. If the soil sample is given like this, if there is only this is a solid, this is a solid plate with no voids or no voids through it, and this another plate bottom where voids are provided for percolation or for seepage, and then the pressure is applied, okay. Sorry, my mistake, sorry, it's my mistake again, sorry. So when the plates, both the plates at top and bottom has voids provided, then the maximum distance the water particle has to travel is D by 2, okay. Again I will tell you. So first, when the soil sample is there of certain height, let's say it is D, certain height, let's say H, certain heights, let's say H, and the plates at top and bottom having seepage pores, so if I consider the half distance here, that is H by 2, this is H by 2, and this is also being H by 2. So any soil particle has to travel a maximum, any water particle has to travel a maximum distance of H by 2. So in our problem, it is given as drainage is provided from both the sides, since percolated plate or plate with voids is provided on both the sides, hence the any water particle can take maximum distance of H by 2 to travel, okay. If there is percolated plate provided only in one side only, then the maximum distance, if there is a water particle here, it has to travel a total distance of H. See, so if both side drainage is provided, both sides drainage D can be considered as H by 2, whereas one side drainage D can be considered as H. So in our case, now this D becomes H by 2, that is 25 by 2 whole square. Okay. From this we can find CV. From this we get CV is equal to 1.217 10 raised to power minus 9. 1.217 10 raised to power minus 1.217 10 raised to power minus 7. No, okay, it's minus 7 meter square per second. Minus 7, 1.217 into 10 to minus 7 meter square per second, that is area per time, okay, area per time. So that is the coefficient of consolidation. This much of area gets consolidated per time, okay. Now as we have found this thing, now next we have to calculate the final thickness of specimen. Okay, to determine the soil permeability, we have to find the soil permeability. in centimeter per second, and then we have to find what is the final thickness of the specimen. Okay, so we will go further down and then we will solve here. So soil permeability, soil permeability K is given as equal to CV MV gamma W. That is soil permeability. There's the many formulas for finding permeability of soil, but if you are given coefficient of consolidation, coefficient of consolidation, the soil permeability can be written as coefficient of consolidation multiplied by coefficient of volume change multiplied by coefficient of volume change multiplied by unit weight of water multiplied by unit weight of water. Okay, so K, that is soil permeability, is nothing but equal to coefficient of consolidation, that is CV, multiplied by coefficient of volume change, that is MV, multiplied by unit weight of water, that is gamma W. So in our case CV we found out as 1.021 into 10 to the power minus 7, but what was this unit? Meter square per second, multiplied by coefficient of volume change, that is 1.215 into 10 raised to power minus 3 meter square per kilonewton, multiplied by unit weight of water, that is 9.81, that is minus 7 minus 3, that is 9.81 kilonewton per meter cube, kilonewton per meter cube. Okay, so it comes out to be 1.217 10 raised to power minus 9, 1.217 into 10 raised to power minus 9 meter per second. Okay, 1.217 10 raised to power minus 9 meter per second. So that's the soil permeability, that is equal to CV MV into gamma MW. So now you have find the soil permeability. Now last thing what the problem has asked us to find out is to find what is the final thickness of specimen. What will be the final thickness of specimen? Okay, so final thickness means after the compression has occurred, what will be the final thickness of the specimen? Means what will be the delta H? What will be the delta H? Not delta H, sorry, delta H is nothing but change in thickness. Final HF, final thickness will be initial thickness, that is H, that is 25 mm, minus change in thickness, that is delta H, that will be the final thickness. Okay, final thickness HF will be obviously initial thickness now since the or initial height, you can also say that, minus change in height, that is delta H, and delta H can be written as equal to delta H by original height H0. Let's say original height be H0 considered as, is equal to delta E by 1 plus E0 delta E by 1 plus E0. Okay, so you have to know that change in thickness, change in height by original height is nothing but is directly proportional to or is equal to change in void ratio by 1 plus original void ratio. So now you can find delta H, that is change in void ratio. What we have found change in void ratio, what was that? Given as 0.92 was the original void ratio minus change in final void ratio was 0.78 divided by 1 plus original void ratio 0.92, and this whole will get multiplied by 25. So we get delta H is equal to 1.823 mm. So final height HF will be equal to 25 minus 1.823. It comes out to be 23.18 mm. So this is where you find the change in final height of the soil specimen after consolidation has occurred. Thank you for watching.